Welcome all of you. So this is the second video in sound. Before this I had uploaded part 1 of sound. Now here in this video I am going to do echoes, mainly echoes and also reflection of sound. So these two things I am going to take up in this video. I shall be uploading a third video also where I'll take up ultrasound in detail. Okay, so let's quickly see reflection of sound. Now what is reflection of sound? Okay, now reflection of sound is very similar to that of reflection of light. Now all of you know reflection of light in that as we know that when light reflects on any surface, this is the perpendicular is called the normal. Okay, the perpendicular to the surface is called the normal. This is the incident light and this is the reflected light. Okay, so similarly in sound also, if this is the surface on which it is reflecting, then this is the incident sound. Okay, and this is the reflected sound. This is the incident vibration, this is the reflected vibration. Okay, and what is equal is this angle. This is the angle of incidence of the sound energy, the sound vibrations that were falling on the surface. This is the angle of reflection. I is equal to R for even in sound. Okay, just like in light. Similarly, another thing, that is the incident vibration, the reflected vibration and the normal all lie in the same plane. Now this is very similar to that of what you know as reflection in light. Okay, you might not have done reflection of light this year, you will do it next year. Okay, you will do it in 10th standard, reflection of light, where you learn all these things. I is equal to R and incident ray and reflected ray and the normal all lie in the same plane. Now reflection of sound, it happens in many things around us and in many instruments make use of this reflection of sound. Like we have the stethoscope, okay, used by doctors, that actually makes use of reflection of sound, and the reflected sound goes from our body to it reaches the ear of the doctor. Then we have the megaphone. All these things, okay, are based on reflection of sound. Now the thing is, when sound is produced in an auditorium, let's say in an auditorium, okay, when sound is produced in an auditorium, supposing here the actors are, whatever is happening on stage, the stage is here and the audience is seated here. Okay, in that case, the sound should reach the last person also clearly. For that what they do, they will make the ceiling slightly curved so that the reflected sound reaches them properly. So here when sound is produced, okay, and okay, so if the ceiling is not curved, then the lines, these reflected sounds can go and again get reflected on a wall. To avoid that, the ceiling is made curved so that it reaches all the audience properly. Now this is one kind of arrangement that is used to check reflection of sound. Now what happens is they also keep a sound board. Now behind the speakers also they might keep a sound board which is slightly curved like this. Okay, so these all come under the acoustics of the hall. Sometimes we say the acoustics of the hall is very good, means that there is very little echo, okay, there is very little reverberation, and the sound, whatever the people were saying, whatever was the show, that came very clearly to the audience. That is when they say the acoustics is very good. Now if sound is produced here, they also make sure to put this sound board, as I was saying, and here, so that the sound gets reflected evenly to the audience. So these are some measures they take to check reflection of sound. I just talked about echo, I just talked about reverberation. Okay, let me now tell you what exactly echo is. Echo is a reflection of sound. So if you have, now what happens is, if supposing you are sitting in a hall, you will see when you go to a hall or an auditorium, to a good if the auditorium has good acoustics, you will see that the seats are very much padded. Even in a when you go to see a movie, okay, the hall will have the seats are very well padded. Not only that, the walls will be little rough made. Sometimes the walls are also padded, or the walls are little, the texture of the wall is little rough. Now, why do they make all this? Is to avoid unnecessary reflection of sound. If they make the wall very, very polished, or the seats are made with very straight surfaces, not cushiony, then what will happen is the sound will get reflected from everywhere. So, to stop that, what they do is they make the walls textured, and the seats will be little cushioned, so that they absorb sound energy. Okay, so unnecessary sound and reflection is reduced by this method. Okay, then also we say that the hall has a very good acoustics. Okay, now let's come to what is an echo. Now, if you are in a room where there is no furniture, only the walls, an empty room, okay, then only you can hear a proper echo. Or you have gone to a temple with a big shrine, okay, or you've been to a church, okay, so and you go and speak there, and there are not many people, and you will hear the sound coming back to you. Okay, if it is coming back to you clearly, loud and clear, okay, it is an echo. So it sound, you are speaking here, and this is the, whatever hall you are standing in, sound comes, reflects back to you. Okay, sound goes and reflects back to you, and that you hear, that is an echo. If it is clear, okay, so it won't be as clear as the original sound, but if it is more or less clear, we call it an echo. But the thing is, if that sound, if the sound is undergoing multiple reflections, okay, it is undergoing lots of reflections here, and all over the room it is getting lots of reflection, and they are all coming back to you, okay, you can't hear the sound clearly, okay, all you hear is some blurred sound, okay, unclear sound. There's a kind of it's kind of lots of sounds coming together, a humming kind of sound. Then it is called a reverberation. Okay, basically reverberation is the persistence of many echoes. Okay, so persistence of many echoes produced in a place, but then the effect of reverberation is unclear and blurred. Echo is much more clearer. Okay, so echo is just one single reflection, whereas reverberation is many reflections coming all together. Okay, so that is an echo. Now here we want to hear what exactly should be. Then just now I was talking about the echo has to be clear. Okay, what has to be the minimum distance for the reflecting surface for you to hear the echo clearly? Now listen to this very clearly, because this is something they give in the question paper. They ask you to derive also. Now what is it? When we talk or somebody talks, the sound has to be processed, means through our ear it reaches our brain, and then the brain interprets it, okay, and tells us, okay, what is that person saying. Okay, we need to understand the meaning of that. So all this process takes 0.1 second. Okay, this is called persistence of hearing. Okay, what is persistence of hearing? The time taken by the brain to process it. Okay, so if any other sound reaches our ear before this 0.1 second, that is 1/10 of a second, we don't understand it. Okay, not that we don't hear it, but we don't understand it. Okay, so that is why we need a minimum distance. We need, if this is the place where I'm standing, okay, and I talk here, there has to be a minimum distance after which the echo has to reach my ear. If this is the obstruction, okay, this distance, there has to be a minimum distance. Only then I get that 0.1 second to understand the previous sound and then to hear the echo. Now, if I have spoken, that sound is already being processed in my brain. So, if I hear the echo within that 0.1 second, I will not be able to hear the echo or understand the echo. So, there is a minimum distance. What is this distance? I'll take this distance as a d. Okay, twice this distance is a 2d. Now, the sound that you have processed, one sound you are hearing, that is immediately happening. The other sound has to go and then come back. So, it travels distance 2b, 2d. 2d is velocity of sound. This is distance is speed into time. Okay, now here it is 344 meters per second. 344 meters per second into what time should it take? It should take a minimum of 0.1. Yes, of course it can take more. Okay, that is 34.4. D is 17.2. Okay, so D is a 17.2 meters. So the minimum distance which where the reflecting surface should be of 17.2, at least 17.2 meters. It should be far from you. Okay, so that is one very important question. Okay, now here we have two questions. An echo was heard after 3 seconds. What is the distance of the reflecting surface from the source, given that the speed of sound is 342 meters per second? Now here is the source, here is the reflecting surface. If this distance is d, for our sound, because it's an echo, sound has traveled from here to here and back here. So the person, after that the sound is produced from the source, it has gone and then come back. So 2d is the distance every time if the source itself is hearing the echo, then you take 2d. Now here 2d distance is speed 342, okay, and time is 3 seconds. That is the total time taken to cover this distance 2d is 3 seconds. Okay, you can also take d and 1.5. Okay, so d here is, this is, if I divide with 2 here, it becomes 171 into 3, which is 513. 513 meters is the distance of the source from the reflecting surface. Okay, generally echo questions are simple. Person clapped his hands near a cliff and heard the echo after 5 seconds. So the person itself is the source. What is the distance of the cliff from the person? So the person is, again we'll take 2d. This is the distance of the cliff from the person, and the time is 5 seconds and the speed is 346. So quite similar questions. Okay, only thing is, remember to take 2d only when the source himself is hearing the echo. Okay, if they make a twist in this question, I'll come up with many tough questions later on where the source himself is not hearing the echo, but someone, over here is hearing the echo, then the question changes. So here 173. So 865 meters is the distance, okay, of the source and the echo. So that was it in this video, few of the important things of reflection of sound. In my next video, I'll be coming up with ultrasound. Okay, lots of things about ultrasound and lots of give reason questions which can come as give reasons. Okay, then if you have not subscribed, please do not forget to subscribe. Okay, because now a series of 9th standard videos are going to come up. Thanks all of you. Bye then.